Hi everybody. So today we are continuing on with lesson 5.2. So this is going to be looking at some workbook examples, looking at some word problems. But to begin, to solve two-step equations, we're first going to look at what this means with algebra tiles. Okay, because I want you to have an understanding of why do we have to do something to both sides of our equation? Why is that so important? And so hopefully you remember from a while ago using algebra tiles. So we're going to represent x with this little bar. A positive one is going to be an empty pink square, and a negative is going to be that pink square shaded in. Okay? So important concept of algebra tiles is if you have a positive and a negative, positive one and negative one, you add them together, they give us 0. They form a 0 pair. Okay? So whenever we try to make something cancel, we try to make 0. So let's begin by looking at this equation over here and representing it with algebra tiles. So we have 5x minus 2. So that means we have 5 x's. So I'm going to draw 5 bars to represent 5x. Let me squeeze one more in there. Okay, so there's my 5 x's, and I have a negative 2. So I'm going to represent that by drawing 2 shaded in squares. And over here, I have 13. So I'm going to draw 13 squares. Now again, my goal in solving an equation is to isolate my variable, to get one x by itself. So I want one bar. But right now, I have these 2 negatives. So in order to get rid of those 2 negatives, I have to add 2. So now I have a 0 pair, and I have another 0 pair. I have a negative and a positive, makes 0. So those cancel out, but I have to remember whatever I do to one side, I have to do to the other. So I'm also adding 2 positives over here as well. And so what we've really just done to our equation is we have 5x minus 2 is equal to 13. And we just added 2 to both sides. So now those canceled, and we have 5x on this side. On this side, we have 13 plus 2, and we got 15. Now we need to figure out what 1x is equal to. Well, what I can do here now is I can regroup my 15 ones. So I'm going to regroup into groups of 3, because then I'll end up with 5 groups. So I can see 1x, each x is equal to 3. So if I want to know, if I want to get rid of x, I would get rid of 3 here. If I get rid of another x, get rid of another 3, another x, another 3, another x, another 3. So I'm left with x is equal to 3. And what we really did here is we took that 15 and divided it into 5 groups. And what we're left with is one group of 3. So x is equal to 3. Okay, so there's one example. Let's look at this example here. So this time they say a half x plus 6. So I'm going to imagine my x is about this size. But I'm going to draw it half that size since I have a half x. Okay, so it's going to be like that. And then I have 6 ones. And on this side of the equation, I have 10 ones. I'm going to erase this. Okay. So again, I have to get rid of these ones. So this time I have positives. In order to get rid of it, I have to add in 6 negatives. And whatever I do to one side, I have to do to the other as well. So now I'm going to see what forms our 0 pairs. So this positive and that negative, positive, negative, all those cancel out. And same on this side. And so what we have really done here is we subtracted 6 to both sides, right? I added 6 negatives. So you got half x is equal to 10 minus 6. We're left with 4 ones. So I'm going to get rid of the rest of this. It disappears. So my half x is equal to 4 ones. Well, what if I had a whole x? What if I added the other half? Well, then I would have to add 4 ones, right? So I just am doubling both sides. So all I'm doing here in my equation is I'm multiplying by 2. 2 times a half, I get x. 4 times 2, we get 8. So there's my final solution. So that's using algebra tiles. Hopefully that kind of helps you see why we do what we do with our equations. Why we add, or why we subtract, divide, or multiply. All right, so let's look at some word problems now. So this is example 1 in your workbook. This is on page 270. It says Nayla and 2 friends spent $21 on movie tickets and a box of popcorn. How could they figure out how much each movie ticket cost? Okay, so in total, they're spending $21. $6 they spend on popcorn. So I have to figure out how much they spend for each ticket. So I'm just going to write myself a little note. All of this is $21. If they spend $6 on popcorn, guess how much they have left? Well, 6 minus the 21. That means for all of this, they spent $15. And there's 3 tickets. I bet you could figure out how much each ticket's worth. But before we do that, we're going to look and see how we can represent this with a bar diagram. So the total cost, the $21, is equal to each of the movie tickets plus $6 for popcorn. So from here we can write an equation. We have the total spent is equal to 3 times the cost of 1 movie ticket because they're buying 3 movie tickets plus the cost of popcorn. So the total spent is $21. The cost of 1 movie ticket, we use that representing M as that variable, and the cost of popcorn was $6. So here's our equation. 21 is equal to 3M plus 6. So the first thing we have to do, again, we're using PEMDAS, but going in the opposite order. So here, I see multiplication and I see addition. So the inverse of multiplication is division. The inverse of addition is subtraction. So I'm using division and subtraction. Subtraction is what comes first now. So I have to begin by subtracting 6 to both sides. We're left with 3m. Over here, 21 minus 6, we have 15. 15 is equal to 3m, right? That's what we said. We subtracted the 6 over here, the cost of the popcorn, and we saw for the 3 movie tickets, it cost $15. So now we have to divide by 3 to figure out how much each movie ticket costs. So 15 divided by 3, that's $5 per movie ticket. All right, try this problem. Andrew rents bowling shoes for $4. He bowls 2 games. Andrew spent a total of $22. How much was the cost of each game? Okay, so we know to begin with, he has to pay $4 just to go bowling because he needs bowling shoes. So we have the $4, and I don't need to keep dollars with it, so I'm going to erase that. But we have 4 plus, he bowls 2 games. So 2 times the cost of each game. So 2 times B, and that's going to be equal to our total, 22. So remember, the one-time cost plus B is our rate, the cost per game, and we have 2 of them. And then that's equal to our total. That's how we set our equation. And now I just have to solve. So we start by subtracting the 4. We subtract 4 from this side, we get 2b. 22 minus 4, we're left with 8. And now we can divide by 2. So b is equal to 9. Let's try another example. Example 2, John has 21, this should be 61, balance on a gift card that can be used to purchase online music. He bought some songs that each cost $1.29. Now he has $10 left. How many songs did John purchase? So you guys might want to do this without writing an equation, which is great because that means you really understand what you're doing, but it's important that you still use that equation because we need to be able to understand where the equations even come from that you see later and how to manipulate them. So first we need to write the equation. All right, we have 2161, that's our total. The 129, that's the cost per song, that's our rate. So remember, our rate means that's our coefficient. That goes with some variable. And then he has $10 left. So if you think about the money he has $10 plus the money that he already spent. So the amount of money that he had to begin with is the $10, the amount that he has left plus the money that he spent. That makes up the 2161. So 10 plus 129, that's our coefficient, and we have to multiply that by the number of songs that he purchased. It doesn't give us a variable here, so I'm going to use S for songs, the number of songs. And this is equal to our total, 2161. Now all we have to do is solve the equation. So again, if we think about PEMDAS, working our way backwards, what operations do we see? I see addition and multiplication. So that means the inverse operations of those, I'm going to have to subtract and I'm going to have to divide. So what are we adding? We're adding 10. So what do we have to subtract? We have to subtract 10. So subtract 10 from this side. All we're left with is 129s. Subtract 10 from this side. 21.61 minus 10 is 1161. My next step is to divide. So I have to divide 129 from both sides. So S, 1161 divided by 129 will give us 9. So we bought 9 songs. Example 3. The number of trumpet players is 2 more than a fourth of the entire band. How many students are in the band? So these are the lovely, interesting word problems that you wouldn't really ever see in real life, but they like to throw on there just to, basically make a riddle out of words, I think. So the number of students, the number of trumpet players is 2 more. 2 more. Remember, more means add. Then a fourth of, remember we said of is multiplication, a fourth times the entire band. Do we know how many players are in the entire band? No, that's what we're trying to solve for. So that's our unknown. That's going to be our variable. So I'm going to make that B for band. So we have 2 plus 2 more than 1/4 B. Oh, actually, I believe there's an important piece of information that we're missing. If you look in your workbook, it'll tell you. But it says there are 18 students that play the trumpet. So this is going to be equal to 18. Our total is 18. So the number of trumpet players is 2 plus a fourth of the band. The total is 18. So now we could solve. So subtract 2. We have a fourth B, right? These cancel. Is equal to 18 minus 2. We get 16. And now we need to multiply. So you can say a fourth times B, or you can say this is B divided by 4. If you multiply these together. So you can say either I want to divide by 1/4 or I want to multiply by 4. Dividing by 1/4, in order to divide by a fraction, you have to multiply by the reciprocal. The reciprocal of a fourth is 4. So multiply by 4. That just gives you 1B. 16 times 4, you get 64. So there's 64 people in the band. B, the number of people in the band is 64. All right, try it. Kirsty ran 24 miles in a charity run and then walked 0.2 kilometers to the presentation table. The total distance Kirsty traveled was 26.9 kilometers. What was the distance of each lap? Okay, so she ran 24 laps and then she walked 0.2 kilometers. The total distance was 26.9 kilometers. We don't know the distance of each lap, right? That's what we're trying to solve for. So we're going to say D, our unknown, is equal to, well, we could say the number of kilometers in each lap or the distance per lap. So To set our equation, you can say, okay, what's our total? Our total is 26.9. So we're going to have something equal to 26.9. This is the distance she went for the race. I'm actually not going to put units. You know that's kilometers because our problem tells us. So this is how much she traveled. Well, how did she get there? She ran 24 laps plus walked 0.2 kilometers. So 24 laps times d, times the distance, right? We want to find out the distance. And then we have to add that onto the 0.2 kilometers. So this is the distance that she walked. This is the distance she ran. We get the distance she ran by multiplying the number of laps we ran times the distance around the lap. So if it's 1 kilometer, then we ran 24 kilometers. Now we can solve. So first subtract. So here we get 26.7 is equal to 24d. Divide by 24. And you're going to get some decimal for that 1.1 something. We'll have to look. All right, guys, but that is it for today. Now I want you to try the workbook problems, and good luck.